AI agents are evolving to work like humans. They can now reason, they can take up to 30 minutes to complete a task, and they can even take control of your browser. But unlike humans, currently agents don't learn from their mistakes. Every time you run an AI agent today, it sort of like wakes up out of nowhere and it has absolutely no memory of what's going on. So in the first part, I will give you a quick overview of what agentic memory is. And then in the second part, we will go over a practical tutorial of building AI agents with memory from scratch. So let's get started. So before we dive into the practical part, let's first understand what really agentic memory is and how does it work. And of course, the easiest way for us to do so, that has already proven to work extremely well with AI, is to compare how it works in a human brain. So when it comes to memory in humans, there is short-term memory and there is long-term memory. Short-term memory is responsible for remembering only a few things for a very short amount of time, like when you're dialing a number on your phone that you just saw on a website, while a long-term memory is responsible for remembering information from days, weeks, or even years ago, like for example, how your past birthday went. And when it comes to AI agents, guess what? Both of these memory types can also be mapped out to specific agent components, which is exactly what authors of this paper, Cognitive Architectures for Language Agents, attempted to do. So in AI agents, the short-term memory is essentially the conversation history, the results of tool calls, and the attention layer of the underlying LLM, which is what the agent is currently focusing on in the conversation history. And the long-term memory, however, is more complex. And in this paper, the authors have further broken it down into three subtypes: procedural memory, semantic memory, and episodic memory. So procedural memory, which is how we perform the tasks, is essentially your system prompt. Episodic memory, which is recalling specific past events, is few-shot prompting. But the type of memory that we will be focusing on today is called semantic memory, which is about recalling facts. And I'm pretty sure most of you guys are already familiar with this type of memory in AI agents, because semantic memory is just RAG, or Retrieval Augmented Generation. It's just using a vector database to perform a semantic search. So you see, it's semantic memory in humans and semantic search in agents. Like always, the components of a human brain map together quite nicely with the components of AI agents. But now, when it comes to actually building semantic memory in agents, typically you have two options: a standard background approach and a more novel, fully agentic approach. The background approach is essentially how it always used to be done. You just process your data in the background, like for example, after a customer support agent has handled 1,000 tickets, you extract key details from these tickets and then add it to your agent's knowledge, which is a vector database. But today we'll be looking at a more novel agentic approach, where the agent determines by itself whether it needs to update its own memory or not, which is a lot more natural both for the agent and for the user. So as I will show you in a bit, it's incredibly powerful. The agent literally learns by itself almost after every single message and almost after every single tool call. In my demo, it literally prevented the same errors that it did before in the previous conversation by itself. And this is actually the next thing that I want to quickly go over, because the benefits of agentic memory are much bigger than you might think. The primary benefit is not even the context or fact retrieval by itself, it's self-improvement. You see, memory is the easiest way for you to create self-improving AI agents, because agents can literally remember their own mistakes. You simply add 3 tools to an agent and then instantly the agent can self-improve. And the second key benefit is personalization. Personalization gives your agents a very unique competitive edge, because if your agent knows everything about your client or your users, it is instantly more valuable for them, and thus it also makes it much harder for them to switch to another solution. Like with ChatGPT, I don't even care how good Claude is because ChatGPT remembers literally everything about me and my business. So when I ask it to draft an email, the result is always 10 times better, even if Anthropic has a slightly smarter model. So now, when it comes to actually building memory in your agents, you have 3 options. You can use a vector database, you can use a framework that supports memory out of the box, or you can use a special memory layer platform. So let's quickly go over each one and then we'll actually get to building them. So with the first option, you can actually use any vector database of your choice like Pinecone, Wave8 or others and build your own memory layer from scratch. This approach gives you the most control, but obviously it requires a bit more work. The second option is to use a built-in feature within an agentic framework. Many frameworks today, like Crew AI and LangChain, already support memory out of the box. However, this is actually my least favorite approach. It works well at the start because it requires very minimal development effort, but as soon as you go into production, it instantly becomes limiting because you have no control over how the memory is processed and what the agent actually remembers. And the last and my preferred way of creating memory that we will implement today in this video is to use a specialized agent memory platform. Some forward-thinking startups have already attempted to create memory layer for AI agents, so all you need to do with such platforms is just hook up to their APIs and that's it. This option provides you a very nice balance between control and the development effort. And the platform that we'll be using today is called Mem0. From our experience, it's the best right now because it is fully open source. So you can even run it locally, or you can use their platform, which also has a very generous free quota to help get you started. However, I do think that OpenAI will also soon release memory in the API, which will then be our preferred option. Now, let me finally show you how to create agents using Mem0 completely from scratch. Okay, so for this video, we'll be using our own agent framework called Agency Swarm on GitHub. And I just wanted to mention that we just created proper documentation, which you can find right here. I personally spent over 40 hours writing this documentation, and it has basically everything you need to know to get started and fully understand our framework. It has a very nice description of all key components, like for example, what are the tools, what are the agents, and also a lot of cool explanations on all of the additional pro features that not so many people know about, like custom communication flows. Okay, so let's proceed. The first step is to create a repo. So go to your repositories on GitHub, click new, and then name your repo and hit create. Now hit open with GitHub desktop and make sure to copy it locally. Now I'm gonna open it in Cursor. Awesome, now we are almost ready to get started. So of course we'll be building our agents using other AI agents. Specifically, we'll be using Cursor agent to build these agents for us. So what we need to do before we can use our framework with Cursor is copy this special Cursor rules file. So simply go to this file, then hit download raw file, go back to Cursor, and then add it on the left. We are constantly updating this file to align with the latest features in the framework, so make sure to update this file frequently. After you added this file, Cursor will know everything that it needs in order to create agents with Agency Swarm. As you can see, it contains all of the instructions on how to build agents with our framework. So next, let's create a Python virtual environment. So simply hit Command-Shift-P or Control-Shift-P on Windows, click Select Interpreter, create virtual environment, and then select venv and the latest Python that you have installed. Awesome, now we are ready to get started. I will be building agents with Cursor Composer, agent mode on, and the agent that I will be building today is going to be a customer support agent with a few tools. So first it will have 3 tools to read memory, update memory, and delete memory. And then it will also have a simple make a refund tool. So the idea is that the customer support agent needs to learn the preferences of the user and to also correct its own mistakes. So the purpose of a make a refund tool will be to test how the agent can remember to learn from incorrectly performing a refund before. Okay, so now I'm just going to explain all of this to Claude 3.5 Sonnet. You can also try other models, but I actually found that right now O3 Mini and O1 are not working properly with Cursor Agent because there are some issues with function calling in these models. Okay, so here's my prompt. As you can see, I spent quite a bit of time on it. In your prompt, make sure to specify, of course, the agents that you want to create, how these agents should operate, and also the description of each tool. So I added a clear description of all 4 tools, including what parameters these tools take, how they should work, and what they should return in their outputs. But the problem is that, of course, Cursor doesn't know how Mem0 API works. So what we're going to do next is we're actually going to go to Mem0 documentation like this. So simply search Mem0 docs and then open the page that contains the necessary documentation for our tools. So I suppose for us, the quick start documentation is going to be enough. So what I'm going to do is I'm going to simply copy this documentation and then add it in a prompt just like this. Now Cursor will have access to how Mem0 API works, which should help it to generate a lot more accurate results. So whatever API you use, make sure to do the same. If you are building agents with any third-party APIs, make sure to include this link to documentation in your Cursor prompt. Okay, now let's hit submit. And while the agents are generating, let me go to Mem0 dashboard and let's actually create our own API key. Awesome, so this is what the dashboard looks like when you sign up for Mem0. And we need to go to the tab called API keys. And here, simply click Create New API Key, name it as your key name, and then click Create API Key. After that, copy this API key. Make sure you also have your OpenAI key. And now let's see what Cursor has done so far. So seems like it's only starting to create agent folders. So I'm gonna hit Accept. I'm gonna click Run Command. And then let me just wait until all of the agents are created. As you can see, the add memory tool is quite close. It does use the Mem0 client, just like it is described in documentation, even though Claude 3.5 Sonnet obviously has no knowledge about how their API works, because the knowledge cutoff is actually much earlier than when it was developed. Okay, so now it seems like all of the tools and the requirements are created. And currently Cursor is creating the customer support agent itself and the instructions. Instructions are obviously not going to be very accurate. I'm going to show you how to fix them later. But overall, as you can see, it's pretty much there. So this already gets us like 80% there. But typically, when it comes to developing tools with Cursor, there are always some adjustments that need to be made, or there can be some errors in the implementation of the tool. So to speed up the process even further, we don't want to test and look for these errors ourselves. We can actually tell Cursor Agent to do it for us, because Cursor Agent can actually run and test your code for you. So let me now send this prompt. So I'm simply going to say, please now test all tools to ensure that they work correctly. Oh, it actually even reminded me to add the API key into the end file, because I actually forgot to do this myself. So let me now add this Mem0 API key in the .env file. And also don't forget to add your OpenAI key here as well. And also what we need to do before we can actually run the tools, one more thing that I completely forgot myself, is to install the requirements. So simply open the terminal and then run pip install requirements.txt. Just like this. So it seems like the version for Mem0 is incorrect. So let's go back to their documentation. As I said, Cursor can make mistakes. Don't expect it to complete it perfectly from the first attempt. That almost never happens, only with some really simple agencies. So right now you do have to iterate with Cursor before you can get a working demo. So let me add the correct package name into the requirements. Let's also install the latest agency swarm. Make sure to update it if you installed it before. And now let's run the requirements.txt again. All right, so now that the requirements are installed, Cursor should be able to test these tools for us. Okay, so as you can see, now it's attempting to test the add memory tool. So let's allow it to run this command and see if it works. Okay, so as you can see, there is an issue as expected, and now it's trying to correct itself. Okay, so it just adjusted all of the memory tools, and now it's trying to test it again. So let's accept the changes, and now let's run the command. Awesome, and now as you can see, the memory is successfully stored with ID. However, it seems like the ID is not returned, but it's not a major issue, so we'll fix it later. Cool, so it seems like the search memory tool works as well. The delete memory tool has a small issue, and the make refund tool also has an error, but as you can see, cursor is already on it. All right, perfect. Perfect, and now the make refund tool is fixed as well. So it seems like all of the tools except the delete memory tool are now functional. So what we can do from here is simply adjust the tools that are still not functional manually. So let me open the delete memory tool right here, and let's see what the issue is. So as you can see, cursor added a test case here at the bottom, so you can actually test the tool yourself. You can simply run this file, and then you will see if there is an error, or if the tool works correctly, you will see an output. So it seems like there is a 400 bet request error. So what we need to do in this case is find again the most relevant documentation. So let me go back to mem0, and here let's find the delete endpoint. Okay, so as you can see, this is the documentation for delete memory. So let's simply copy this Python code snippet. Then let's go back to cursor composer, and then let's just send this documentation to it and tell it to fix the delete memory tool. All right, and now it seems like the tool is working properly because it says that the memory not found. So it means that the tool does call the API correctly, but we just don't have that memory stored in there. But I do want to add one more adjustment. Specifically, I want to save memories by user IDs. So I want each user in my application to have completely distinct memories from other users. This way, the agent can learn preferences of each user separately. So for this, in mem0, there is actually a cool parameter called user ID. So whenever you call any methods like client delete, you can add user ID just like this. And the user ID itself, I will actually add in the agency.py file. So in Agency Swarm, we have this advanced feature called shared state, and shared state allows you to share different variables between all your agents and all your tools. So this is the best way to specify which user ID should be used for this interaction, because typically, of course, you don't want the user to provide its own ID. That would be just a bad user experience. So you want to set this before the start of your application. So when we launch our agency, I'm going to add here support agent set shared state user ID, and I'm just going to use user ID 123. Awesome. Now, when using the delete memory tool and all other tools with mem0, we can access this shared state by using self_shared state get user ID. So like this, the memories will be stored and deleted for each user separately. So let me now add this to the two other tools, and then I'll show you how to adjust the instructions. So yeah, as you can see in the add memory tool, Claude tried to pass the user ID inside the parameters of the tool, but that's not the best way to do this, because this way one user can fake someone else's user ID and then add some inappropriate preferences. So let me delete this parameter, and then I'll access the user ID from the shared state. So now we are ready to adjust the instructions. So in your instructions, I typically like to specify the agent role, the context, and then also the process workflow, which are like the specific instructions that the agent needs to follow. So don't rely on cursor for generating instructions. I actually recommend that you write all of the instructions completely from scratch. So what I'm going to do is I'm just going to delete all of this, because honestly, the instructions that cursor comes up with right now are not really realistic. We'll probably fix this sometime later, but now I'm just going to work on these instructions myself. Okay, so here are my instructions. First of all, you need to prompt your agent to always check the memory first before responding to the user. Then you need to make sure that the agent saves all of the relevant information. So in your prompt, also make sure to specify exactly what the agent needs to save in memory. So here I'm saying that it needs to save things like customer name, email, phone number, order history, and so on. And then also, here's a cool part, you can tell it to remember what errors it encountered before when using other tools. So here the idea is that the agent will get an error when using the make refund tool, because here I told cursor to add some non-refundable items. As you can see, for example, like dairy and fresh produce are non-refundable. So then when the agent tries to refund that based on the user's request, it's going to get an error, and then it should remember that error, so in the future it does not repeat the same mistakes. And lastly, at the end, I'm just repeating some key information. That's also a good idea. Like I said in my previous video, you need to put the most important information at the end of your prompt. Perfect. So I think now we are ready to run this agency. There's also an agency manifesto. However, I'm actually not even going to be using it here since it's just one agent. So if you have multiple agents and they are all using memory, this is actually where you can put the instructions on what to remember. Awesome. So let me run the agency.py file. And as you can see now, the agency is working. So let's say, hello, I am Arseny. Incredible. So as you can see, the customer support agent then immediately saves my name using the add memory tool, and then it greets me accordingly. So let me actually test it now. Let's test it right away. Let me close this chat and then let me restart it again. So now it's going to be like a new conversation. As I said before, the agent is now like sort of waking up out of nowhere and has no idea about what's going on. But now if I ask it, what's my name? It actually says that my name is Arseny. You see how powerful this is? Now the agent doesn't just restart from scratch on every single interaction. It actually remembers stuff from previous conversations. So what I'm going to do now is say that I have a problem with my recent order. So it checked memory again, but since there's no memory, it's now asking me to provide more details about the issue. So I'm going to say that I want to refund a dairy product that I just recently ordered. So as you can see, now the make refund tool returns an error that it cannot process a refund for a dairy product as it contains non-refundable item type. And then the agent actually saves this to memory. So as you can see now, the agent used the add memory tool and then added that the dairy products are not refundable. Okay, so this is the key thing that I wanted to show you. Now, if I restart a conversation and then I say again that I want to refund a dairy product, the agent uses the search memory tool, and then without using the make refund tool, it tells me that unfortunately dairy products are non-refundable. So as you can see, this is incredibly powerful. Of course, this is just a simple example where we have a very simple dummy make refund tool. But imagine if it was a real make refund tool and if the customer actually got a refund for a product that was already refunded before, or that is simply not refundable. That could cause significant issues further down the line. This is why memory is so powerful. It helps you to prevent mistakes and improve the agent's performance. Like another example where this could be incredibly powerful is a database agent that performs queries on like hundreds of tables. But what happened in our agency is that typically, customers don't have clear descriptions of each of those 100 tables. So what you can do is you can create a database agent that doesn't just perform queries, but also remembers the client feedback. So like, for example, if it performed an incorrect query once, the client can then tell this agent that the proper table for such query was another one, and the agent will remember that information. And then the next time they use this agent, it will actually use correct table. This makes it incrementally more powerful. So the more you use this agent, the more powerful it becomes. So all of the code for this video will be attached down below. We'll also probably improve these tools a little bit further. And then if you don't want to build them from scratch, you can simply copy them from this memory agency folder and then add it to your existing agents. Thank you for watching and don't forget to subscribe.